Size and scale of geology. The first one is global scale. At the global scale, geologists study the entire Earth as one system. This includes things like plate tectonics, climate patterns, and distribution of continents and oceans. So this would be measured in kilometers of thousands, and an example of this would be Earth. This scale helps us understand the bigger picture of processes, like why earthquakes happen or how continents drift over millions of years. At the regional scale, it focuses on the larger areas like mountain ranges, basins, or states. This is where geologists look at how large features form over time. So, like I said, continents, mountains, and countries are an example of these large areas. They are measured in kilometers. An example of this would be Sierra Nevada. This scale helps us understand landscape formation, like how mountains rise or how valleys form. Local scale. At the local scale, geologists study specific locations in detail, often in the field. So this would mean they'd be measured in meters or feet. An example of this would be a cliff, canyon wall, or riverbank. This is where geologists collect direct evidence, like observing rock layers to figure out Earth's history, like we've seen in sedimentary rocks. Hand sample scale. The hand sample scale focuses on rocks or materials you can hold. So this means rock type, the texture, and mineral composition. This would be measured in centimeters or millimeters. An example of this would be a piece of granite or sandstone, or pretty much any rock you can get your hands on. This scale helps identify what rocks are made of and how they are formed. Similar to what we've been doing in class, trying to figure out what rock stage it is at. Microscopic scale. At the microscopic scale, geologists use microscopes to see details that are not visible to the naked eye. What does this mean? For example, mineral grains, crystal shapes, and tiny structures. This is measured in micrometers. An example of this would be a small quartz or feldspar crystals inside a rock. This reveals hidden details like how quickly a rock cooled or what environment it formed in, similar to our igneous, intrusive, and extrusive rocks. At the atomic scale is the smallest level, which focuses on atoms and molecules. So what is this? Chemical composition and atomic structure. This would be measured in nanometers. An example of this would be a silicon atom. This explains why minerals form the way they do and how elements bond together, and how strong they are or how weak they are. The most important idea is that all of these scales are connected. Tiny atomic interactions determine what minerals form. Then minerals make up rocks. Rocks build different landscapes, mountains, valleys that shape the entire planet. So even though geology looks very different and in different sizes, they all somehow work together to explain how Earth functions over time and how old Earth's history is.